Okay, here is the moment of truth. I haven't actually tested this yet. I'm pretty nervous. Here's an old printer cable with a bunch of wires inside. I went ahead and added some of those wires to a handful of ports on my ATmega 48. There are quite a few that are still open, but I just left it there. Those run over here, and it seemed like most of the data lines were on this side of the connector, so I went ahead and connected them there. I also hooked up the oscilloscope to, what wire is that? Blue solid, so I can see what it looks like on the screen. This is what it looks like on the scope, and I imagine you can see that on the camera. To give you an idea of how quickly it's going, I imagine I'll see this and some other data coming through as well. So when I look at the live view, this is what I see, and I think this is updating this column right here every 1/10 of a second, so that probably changes every time my frequency counter changes value. But enough with that, I will go ahead and configure it to log. So live is false. Save, run. I'll maybe get several seconds, and you can see the rate at which it's capturing. It's almost 1 kilohertz. It's a little bit less, so that should be enough. So I will now graph it, and forgive my program as far as the visualization goes. It's very quick and dirty, but it works. Okay, these are all of the wire colors. I labeled them all. Let's see what's the best way to do this. Alright, at the bottom you can see that clock, this really slow clock, that changes every time the frequency is updated, so 10 times a second on its current mode. A moment of truth. I'm so nervous right now. Okay, I'm going to zoom in here. Okay, we see some data. Looks interesting. It doesn't look like I'm capturing everything I need to capture. My sample rate's still not quite high enough. Here is I don't think this is 1/10 of a second. I'll probably have to look at it a little bit closer and actually get a good idea of what all this is. Yeah, I imagine I have to look at this closer. I don't think I'm capturing everything I need to. But I might be. This data down here looks pretty interesting. I'm wondering if some of these little spikes are transitions. Well, the bottom line is the logic analyzer I made just by reading raw digital values on the input pin seems to be working. I think from here my best course of action as far as improvements go lie in having a little bit of memory, and I can load the memory up with some high-speed data and then just use USB to pull the data off. So it looks like 1,000 samples a second isn't quite enough. Oh well, it was worth a shot, and at least we proved that it works in concept.